Hi everybody, my name is George. I'm going to do a video lesson on problem number 8 from chapter 6, session 6, and we will be computing this problem right here. It's an integer between 0 and 1. So the first thing that we want to do when we look at this problem specifically, we want to take out 4 because we want to simplify as much as possible. So I prefer to take out 4 and take it outside of the integer. So now we are left with this. And from afterwards, what I did is I separated 4 from 4 minus x squared, which looks like this. And then afterwards, since 4 can be taken out of the square root, it ended up looking like 1 over 2 times the square root of 1 minus x squared squared. So now I wanted to do a u substitution at this point to simplify things further and make my life a whole lot easier. So we know that x over 2 equals sine u, and I chose to simply put this u substitution back into the equation. So now we see that we have 1 over 2 multiplied by 1 minus sine squared u. As you can see, I just simply replace x over 2 with sine u. And then, because we took the derivative, as you can see in the steps below, we took the derivative of this, we ended up having 2 times cosine u du. So I multiplied this section from here, and I placed it right next to our original expression above. So now we can see that we have 1 over 2 multiplied by the square root of 1 minus sine squared u multiplied by 2 cosine u du. So first off the bat, we see that because technically this is over 1, we can see that we can take 2 out. So I chose to call this step 3.5 by taking and simplifying even further, leaving it with cosine u and then 1 minus the square root of 1 minus sine squared. So now big thing to identify over here is 1 minus sine squared. We know that equals cosine squared u. So I chose to rewrite it, as you can see over here, by rewriting 1 minus sine squared to cosine squared. Again, this is the rule right over here. So now let's see what we have left. We have 1 over square root of cosine squared u multiplied by cosine u. So now we see that because this is squared, we can eliminate the square root, so we're going to be left with cosine u over cosine u. So that leaves us with 4 integral 1 times u. So I'm choosing to undo the u substitution, giving me arc sine x squared plus c, otherwise known as sine to the power of -1 times x squared plus c. So now this is where I simplify the problem as much as I could, and I'm ready to plug 4 back into it, and I'm going to try to solve it with the integral between 0 and 1. And the big thing to realize is that I would have to plug in the integral, and as you can see, once you plug it in 1, you end up getting 4 times pi over 6. We got 4 times pi over 6 over here because this is where sine equals 1/2. And on the graph, to stay within the boundaries of the range between negative pi over 2 and pi over 2, the only possible outcome once we're trying to figure out sine at 1/2, the only possible outcome is pi over 6. So that's how I got pi over 6. And then we have 4 times pi over 6. And then once you plug in 0, it's 4 times 0. And then as you simplify, it's 4 times pi over 6 equals 2 pi over 3. Here's another look over the... Hi everybody, I'm solving the second problem right now, and we're trying to figure out if this is true or false, that arc sine of sine 3 pi over 4 equals 3 pi over 4. So now let's focus in on side 3 pi over 4. I chose to acknowledge that pi equals to 180 degrees. So when I multiply 3 by 180 divided by 4, we see that we get sine is at 135 degrees. And when we look at the unit circle, which is very, very useful whenever you're using pi or sines or trigonometry, we can see that we will end up having sine at the square root of 2 over 2. So now, looking back into it, I replaced sine 3 pi over 4 to simply saying arc sine of the square root of 2, because that's where sine of 135 degrees would lie on the unit circle. So now, if we compute that, we are going to be at arc sine square root of 2 over 2 will equal pi over 4, which is clearly not 3 pi over 4. And we can see this specifically, arc sine pi over 2, by using the unit circle once again, where that would be respectively, and that would be at pi over 4. Thank you very much. Have a beautiful day.